All right, guys, let's talk about solving quadratic equations. And this is just an introduction. There are a lot of methods to doing it. This first method, in addition to having just the introductory information, we're going to also make sure we understand the idea of the zero product property. That's going to help us when we move on to the next ones. But let's just get started here by saying that the easiest way, if you had the graph already, the easiest way to solve a quadratic equation, in my opinion, is to have an actual graph. All right, so we're going to be solving by graphing, and I've already put a graph on here. Doesn't matter what the actual function is, but I'm going to use this as an example. We do know about this thing right here being the vertex. We know that there's a line that goes through this vertical line. We call that the line of symmetry, axis of symmetry. We know about that. We know that it's symmetric across these 2 points right here. All right, this is stuff that we've already learned when we talked about graphing. But the one thing that we didn't talk about really, we didn't really name so far, it's a little bit more than I wanted. One thing that we didn't specify is this thing called a solution. So you see where it crosses the x-axis. So that means the x-intercepts. When you're talking about quadratic equations, the x-intercepts are where the solutions are. So with the star, I'll say the solutions are the x-intercepts. So if I had a graph, a function graphed and it's quadratic, where it crosses the x-axis is where there is a solution. So whatever this function is, the solutions are 1 and 5. Okay, so in this case, x equals 1 and x equals 5. Notice that there are 2 solutions, and when you have a quadratic equation, you could have up to 2 solutions. So when we start solving, you'll see that I'm looking for more than one solution most of the time. All right, let me talk a little bit about terminology. So the solutions and x-intercepts, those are things we already talked about, where it crosses the y-axis. Sometimes you'll hear those same things called roots. The roots of this function, the roots of this equation, I should say, are 1 and 5. Yet another word that kind of means the same thing is zeros. The zeros of this function are 1 and 5. These are all the same. It's when x equals 1 and x equals 5. Those are solutions, the x-intercepts, they all mean the same thing. So if you're given a graph, you can very easily see that. Now the reason why that's important, and I really wanted to use that word zeros right here, because there's this idea that, whenever you try to solve a quadratic equation, you must have this thing set equal to 0 first, because I want to know when the function equals 0, when the y value is 0, when is it going to happen? All right, it happens when x is equal to 1 and when x is equal to 5. So if I have some function, and I say that the function is like x squared minus 4. If that's my quadratic function, I can solve this quadratic function whenever my y value is 0, whenever I have a 0. So if I write this, then I can solve this equation using one of the methods. And even though we'll learn about this later, there's this idea once you actually, and we already know about this is the difference of 2 squares. So I could actually rewrite this as x plus 2 times x minus 2. So I have this product here. Now think about that. Anything or something times itself equals 0 only when this is 0 or that's 0. Like 7 times 0 is 0. Or 8 times 0 is 0. The only time you get a 0 as an answer is when you multiply by 0. So if I'm saying I'm getting a 0 answer, then one of these things must be equal to 0. Now, in order to know which one, I need to let this one be equal to 0. And I need to let this one be equal to 0 because they're both unknown. I don't know exactly which one. So I have 2 possible options, right? Let me draw a line here so you don't think I'm talking about the same function. With the time running out, if I solve this, I'll find that x is equal to negative 2 and x is equal to positive 2. This idea right here is called the zero product property. All right, just wanted to introduce it.